just kind of seeing if
He
he
was
was
just
right.
DRS, but I thought, yeah, he's nice. I don't see him. Can't miss it. Like,
Oh yeah.
Is he going to say then also what I'm going to talk about, like the IO internet, or my title of my presentation? You going to do that? You going to start off what I'm going to talk about?
sure.
Tell him.
Yeah. we'll get started. First off, welcome everyone to the first ISA, IEEE, IAS joint meeting for the year. So ISA is International Society of Automation. We're the local chapter in New Orleans. I'm the president of the chapter. I'm the bad dean. The good dean is the president of the IEEE, IAS, Industry Applications Society. So we were talking, and I had this topic that was offered up. And so I talked to Dean about it, and he said, yeah, that'd be a great topic for our group as well. So that's why we're doing this joint meeting here for both ISA and IEEE IAS members. So, so this presentation is being presented by the New Orleans ISA section. We're working with Reed Shorter here with the Shell Martin Company. They're the manufacturer's rep for Dialite. And then here from Dialite, we have Ken Yusei, who's our local rep, and Glenn Frazier, who will be doing the presentation. So Glenn's been in the automation controls industry for about past 25 years or so, spent the last 3 years in the lighting side of it. So you'll kind of see that the topic we talk about is kind of the bridging between automation and lighting. So I think you'll find it very interesting. If you're interested and you want to get more information on this, quick commercial for you. We are doing a user group session tomorrow. So if you need another PDH and you want another free lunch, you can grab a flyer here. It's at the Marriott Galleria, noon tomorrow. And because this presentation will be technical in nature, non-commercial. Tomorrow's presentation will be product specific, very commercial. So if you're interested, pick up a flyer, you can register and join us. And with that, I will turn it over to Glenn.
All right, thank you. All right, I want to get started with a little bit of history, some quick history on some companies. Kodak, I'm sure most of you remember that. Maybe just the very youngest might not actually remember them for some reason. But in the mid-70s, they commanded 90% of all film sales and 85% of all cameras. They're monstrous. Even by 96, $16 billion in revenue, they're like the top 10 in profitable company in the US. Amazing company, what they were able to do. Still 2/3 of global market share. And then what happened? 16 years later, they're out of business. They're totally gone. So you don't even hear about Kodak anymore. So what happened with that? Well, amazingly, they invented the first digital camera. If you remember, they actually had digital cameras. They had all the software. They had everything, the kiosk, everything going for it. But they still couldn't quite find their way. They couldn't go down that digital path and get to where they needed to go. They just stuck with their film for some reason and thinking that's the way all the profits would come, and they're gone. Now, a lot of you are oil and gas and I'm sure thinking, well, we don't really do products. We've kind of got a commodity. That one doesn't really make as much sense for us. Well, how about books? You're probably saying that's really not oil and gas, but if you think about it, it's not really a commodity, but they're not producing the content at all. They're just taking it, they're finding it, processing it, and selling it to customers. These 5 big companies, you've all probably heard of most of them. Well, they had 80%, or I think it was 80% of all sales, and then Amazon came along. And what happened? Barnes & Noble is the only one still in business now. And actually, they just got bought out last year by a private equity firm. So they're not really even around. So now Amazon's got 80% of all ebooks. I think it's about half of all paper books they're selling, which is amazing. But what happened? Jeff Bezos came in. He didn't do anything special. He wasn't the smartest guy in the room by any means. But he came up with a new process, a new thought, a new way to do it. And he started dominating. And what's sad is you and I could have done the same thing. That we're sitting in the room and I don't see Jeff Bezos in the room anywhere. So it's doable and it's possible, but he embraced new technology, new ways of doing things, and found a way to compete and outcompete everybody else. So with that, let's jump into lighting a little bit and the evolution of lighting. So I went to a Department of Energy lighting show a conference a few years ago. And it was kind of funny. It was a running joke that almost every presentation started with Edison. So guess what? We're going to start with Edison. But actually, it didn't even start with Edison. Most people think he actually invented a light bulb. Light bulb was invented way back in 1802, an arc lamp. Actually, even in the mid 1800s, they had another guy that Mr. Swan came up with the first incandescent bulb. So we had light bulbs for a while. Even the Canadians, they came up, they had a patent. They actually sold light very similar to Edison's. So, but Edison, he had his group of people, and you probably, if you know the history, kind of fascinating to read a history of Edison. You know, he's not necessarily the smartest guy, but he had the vision most people didn't, almost like a Steve Jobs. Steve Jobs didn't develop the things, but he knew the vision where to take his team to get there. And that's kind of what Edison did too. He ended up buying the patents from the other guys and dominated, and especially they loved their monopolies back then. He had a monopoly on all that. But he had this first real light bulb that got out there and was actually able to be commercial and sell lots of them. And oddly, the filament in that was a carbonized bamboo. So that's what they used for the first filaments, bamboo. And oddly got pretty good life out of it, but I'd hate to be the maintenance manager of that factory. Fluorescent bulbs, they were invented in the 1800s. But yet it took almost 100 years to actually become commercially viable and actually selling them. So in the 70s, why do you think it was in the 70s? Why did the people go to fluorescent? Any thoughts? The energy crisis. If you remember your gas lines for gas and everything else, fluorescents all of a sudden took off, and they started dominating the marketplace in that respect for both home and industry. So, and quickly, what you see in the industry is mostly high pressure sodium metal halide. I'm sure everybody's got them in their factory somewhere, or at least piled in a corner somewhere if they haven't gone to fluorescent. A lot of people went to fluorescent, and big incentives to do that the last 5-10 years to do that. Then all of a sudden LEDs came out and started to get more cost effective for this. So now everything's going to LEDs, and there's a reason why. So here's a chart of a bunch of data. I'm not going to decide whether it's exactly 30K or 35 in there. It really doesn't matter. But it is all the different technologies that you have used or have seen, whether it's in your home or in the your plants. But to make it a little easier to look at the basically the relative goodness and badness. I mean, incandescent bulb, about the only thing it's got going for it is really its color rendering. It does give a perfect rendering for a color. But everything else, bad efficiency, horrible efficiency, is about 1/10 of what an LED can do these days. Bulb life is horrible. You start moving into the other products that you typically see, high pressure sodium metal halide. Metal halide is not so bad, except for you start looking at those lifetimes, 20,000 hours. You're talking a year for some of these things. So not very good. And you get to LED, really, aside from the fact it is actually more expensive, there's really no negative to it at all. Maybe the color rendering could be a little bit more perfect, but 90 is pretty good when you're starting to look at high pressure sodium. Anybody's got high pressure sodium, you know the difference. So look at a different way. In this map, this is just two things, the life of it versus the efficiency. And LED really outshines all the other products. So this makes a lot more sense when you're trying why it's starting to dominate the marketplace, especially as costs are coming down. It's starting to make a lot more sense moving to LED, just the capabilities of it, the great lighting, the cost, the no heat, it's just everything about it is, almost everything about it is good. Maybe the very, very, very hot temperatures, if you're over 200 F, maybe you need to use some other product because LEDs, because they are electronic, it might not be able to handle that. But even products like ours, we have some very high temperature more than any others. So there's almost no reason not to use LED these days. And then there is a cost to it. Well, it really comes down to your ROI. You start looking at the maintenance comparison, some of these. Metal halide fluorescent, you're up on the lift every couple years, start to replace bulbs, replacing ballast, maybe every 3-4 years, 5 years on that. Where LED, it could be 5. Most manufacturers are on the 5-year warranty. Ours, we are in 10-year warranty. We specialize in that because we want to make sure you last. So now you can put LEDs up and not touch them for 10 years or more. And some of the lives are 15+ years. Now it makes a lot of sense, but if you're in a classified area, don't even tell me how much it costs to change a light bulb in a classified area. Like kind of the old joke of how many people does it take to change a light bulb? Well, that's in a classified area. It's expensive. So now you can put it up. Most of you people will probably be retired by the time you have to get to the next turn of lighting. Probably myself. I probably won't be selling to the same person twice, most likely. So you see the difference, probably my favorite slide. What is that difference between high pressure sodium and LED? You can see the difference there, washed out a little bit, but in here, it's actually really blue versus a purple motor. There's actually green here. You can't even tell there's a color there. The light, actually even some of the lumen or the foot candles on the floor is could be relatively the same, but the quality is just totally different. So this doesn't show up at an ROI. You can do all the calculations you want, but what is the quality, what you're looking at, what are the maintenance? We actually did a site with an outdoor, I think it was an oil, a refinery. They went out at night and they just replaced some of the lights with LED, and they walked out with the plant manager, and they looked down and there was a poisonous snake sitting there. And you couldn't actually see it before because of the lighting. Now he's like, that's it. We're changing all the lighting to this. So it does actually make a difference. So LED is a clear choice, and everybody's moving towards it. So let's jump back into the Internet of Things a little bit. So what is the Internet of Things? It's basically connecting everything together. So every device you see, and you see all the different pictures in there, whether it's your car, could be your garage doors. I just put a garage door remote for I can open it, my garage door from my phone right now. I love it. You can connect just about everything, and that's what it is, putting a unique address to every single sensor, every single device, everything out there, so you can get that information back. And a little fun fact with that is the unique addressing. That's something called IPv4, or Internet Protocol version 4. If you've ever seen this on your computers, you'll see that IPv4 sitting around. You see an IPv6, because several years ago, they realized that we're actually going to run out of addresses pretty soon with IPv4. So they came out with the new standard IPv6, and the number now is something like, I don't know how to pronounce it, 340 undecilins, which is like 340 trillion numbers. And basically people are saying that the world would become extinct before those actually run out of numbers. So hopefully they have enough. Maybe some of us will make it to retirement by then, I'm not sure. So lots of numbers. Then there's also something called Industry 4.0. So you might have heard this term. So what this is really somebody said there are already three different industrial revolutions. So first one is actually just mechanizing, getting some power to actually do some things. The second is really automation. So here's a slaughterhouse, or could be Ford with his assembly lines, or assembly lines for guns. So it's actually coming up with a process to do it better, faster. And then what we're really mostly still in right now is in the third, which is automation. So PLC. So everybody's got a PLC running their factories. You have robots helping out, automation, all that fun stuff you're doing to really optimize and do better in your plants. But now you're in that last section, or the fourth section. I'm sure there'll be a fifth. I can't imagine what that could possibly be. But that fifth is actually now, that's the Internet of Things, connecting everything together, bringing all this information back and doing something with it, being smarter about it, coming up with it so you can improve your process or come up with a new process or doing something. But that's what that really is, and that's what we're all about now. I mean, today we're connected. I have my iPhone there. I've got my Apple Watch. We're all connected everywhere, and this is what this is. But now, how do you take that and utilize it to do something better with your business? So just a few stats on it. The growth is pretty amazing. So you look at this, it's like doubling every couple of years. So how many devices are connected? So now we're at 50 billion devices that are connected in IoT, which is pretty big. You're looking at it dollar-wise. They're saying in the next 5 years, again, it's going to go up by 8 times to $1.6 trillion of sales for IoT things. So it's out there, it's coming fast, and you're seeing it. I'm sure you're seeing it, and I'm sure you're not even sure what to do with probably 90% of it. And where is it being used? This one actually was even surprising me a little bit. Smart cities. A quarter of them are being sold to smart cities. I'm not sure what exactly to do. I know they're doing street lights and all kinds of things, but I'm not sure exactly what the outcome of that is yet, but that's what they're working on. But if you look at the rest, connected industry, so that's us 17%, plus smart energy, another 10%. You can even look at supply chain. So a lot of it's home and retail, but a lot of it's industrial. So it's coming, and it's coming at us fast. So with it, lots of complexity, because it's not simple. You look at all the data you're getting, how much data you're storing and what you're getting with that. But the possibilities are quite fascinating, what we can do once we figure out how to harness it and really use it for things that are going to be good and help us do better. So to make it a little bit more specific, this is kind of the process of what it does. You know, you're in your business activities. That's what you're doing today. And then you have sensors. Everything has sensors. We've always had those for a long time, and it's creating things. We're getting information. We're doing things with it. But then it starts to get a little more confusing. The data's getting in the middle. So it's the cloud's taking it. You're storing it somewhere in a server. Maybe they're doing processing right at the edge, right down on the production line. So now we're getting all this data, and it's piling up. And now what do? Well, Now that you have to analyze it, which is really the tough thing. If you got this big data, what they call it, it's just piles of data coming at you faster than you know what to do with it. And now there's whole companies out there trying to figure out, how do I take that haystack of data and find the needle so we can do something with it? And that's what the last thing, you take that needle and they have to find some insight to what you're going to do to your process, your business, your whatever, to make it better, and then repeat the process. To look at it a little bit different way, and something that Deloitte had come up with is really a circle where this is where most people are. You're up in the mechanized and the sensor. So now we're all up here. We've got our process, we're getting our data, and we got to now take it and do something with it. So we got to turn it into digital. So integrate it, visualize it, use augmentation. So you're hearing a lot about AI and all kinds of different things. So, and then once you get that, how do you turn that back into something automatically fix your process or improve your process? So to make it a little bit more real, if you look at a couple things. So here's, Deloitte did a study on oil and gas, so upstream, midstream, and downstream. If you look at it, the circles are the maturity, and the shaded areas are where their priorities and what they're spending their time. And if you really think about it, it makes a lot of sense. You're right in the middle there, optimizing operations. I mean, that's what you and I do almost every day. That's what we're trying to do. How do we make something a little bit better, do something? And that's actually where some of the maturity downstream looks like they're claiming a little bit better versus some of the others. But they're getting more mature, but it's really that last thing. How do you create that new value, right? How do you become the Amazon? How do you change something so now you're creating some new product, something better, something faster, something cheaper that you can do something with? And that's where people aren't very mature. They're trying to figure it out right now, all of us. And this is the same with any business. I don't care almost no matter what it is, they're trying to figure out what that new value is. And if you look even just at midstream, again, looks just like most companies. Everybody's in this area. This is where they're at, and here's where they're trying to get to here in the next couple of years. But they're all in this, hey, we've got sensors, we're getting data. Now we're moving in here, and how do we take that haystack of data and analyze it and do something with it? How do we move from that? And then how do we get down to somewhere where we can now automate it and do really good things with it? And that's, again, that's where most industries are. I don't care where you're in, or whether it's midstream here, or whether you're selling potato chips. You're in there trying to figure out how to do it a little better, how to automate it, how to use all this new technology, these new capabilities you have. So connected lighting. So you're probably wondering, how do LED lights fit in with IoT? What's it make different? You know, why does it make a big difference? You have your lights on your ceiling. We've always had our halogens and our HPS or whatever on the ceiling, never really worried about them until they burned out and you had to put a new one up. So the big difference is connected lighting. So now you can connect all your lighting. You can send information back and forth between your lights. You can control your lights. So number one, you can simply control them and do something with it. But now you can get information back and forth. So you have this connected ceiling over your head. And what can you do with it? So it's a little bit more possibilities than you had before. So we look at it in three ways. There's kind of three levels to it, where you have connected lighting, which is your basic connectivity, something you'd even do in your house. I'm sure a lot of you have done connected some of your lights to your Alexa or whatever, and be able to turn things on and off, or my garage door. Then there's next is integrated control. So the capability of now taking that and bringing it and connecting to something else, in this case, PLCs, and let them be the brains to help control your lighting and do something with it. Then if you get really advanced, it's your advanced capabilities, which is kind of everything else. Now you have that. Now you have this connectivity. It's the world of possibilities of what you can do, just like everything else with any IoT application. So let's talk about that a little bit. Connected lighting. So if you get into connected lighting, most companies will do, I'd say, a majority of these things at home. You can probably do everything except for energy reporting. That's really not a home-based type of thing. But on-off controls. You can group your lights any way you want to do it, dim them. You put schedules to turn them on at 8, turn them off at 5 so people don't forget, or turn them off whenever you want. Use sensors, because a lot of your facilities are 24/7. And I get that a lot. You know, we're on 24/7. It doesn't really matter. Well, it actually does matter. When you change, you saw the picture going from HPS to LED lighting. Most of the times they put LED lights up, and if they put controls on, they drop their lights by about 20 or 30%. So you think about your energy right off the bat, they can save 30% of their energy. Then you can start doing other fun things like automatically turn off lines if they're running, or use occupancy sensors. We have daylight harvesting, so if there's any kind of skylights or any kind of sun at all, you can dim lights automatically. So you can have a lot more fun trying to reduce the energy expenditures. Then energy reporting, of course, the ability now to actually see exactly how much you're burning, how much you're spending on all that lighting. You can get that very easily with when you have that connectivity. Then there's integrated control. And I always get asked, well, why would you connect your lights to your PLC? I've got my process. I don't want to get anywhere near that. And those two entities actually never really talk. The lighting people and the automation, it's two different worlds. Well, here's a reason. There's a process, got your soup cans going down, and you've got some kind of a problem. Well, now you can use your overhead light for indication. Hey, we got a jam right here. We have our paper machine, it broke. The web broke. We can start blinking the light, tell people what to do. Now that you're connected to a PLC, you can do just about anything. And that's really any sensor, any process condition, anything that PLC knows, it can now use those lights to help you indicate. And now it's just, lights go from just energy efficiency, which is what you've been doing and why everybody's been going from fluorescent to LED. But now you're actually adding safety precaution possibilities. Maybe it's productivity improvements. Some of those examples could be things like this. You can have your machine running, and if it's, have it down dim to maybe 20% because you're not really there watching it. You don't need to watch it until you have to get after it and do some maintenance. You can then fully stop it and let it go to 100%. So now it's a safety aspect. You can actually put alarms on it, so you actually blink it when somebody breaks a safety curtain, stops the machine, puts the lights 100%. If they do a proper lockout tag out to let them get in there. So you're adding safety productivity to your capabilities. If you have a vessel that's getting overpressured, start blinking the lights, warn people to get the heck out of there because it's going to blow and you're going to have a problem. So steel mills, they love this you can flash lights on the platforms because they're all wearing double hearing protection. They can't necessarily even hear this big train coming in, but it's a safety hazard. And you read these all the time. I get these OSHA reports all the time if something happens where you didn't expect it, but we can help stop that. But anything, connect a fire alarm. You can actually use your lights now. It comes in through your automation and actually turn on rows of egress and blink exits. I was actually talking to one of my old friends at Rockwell, and they had a fire alarm go off, and it was actually a test, but they didn't tell them. Usually they tell them. It happened to be their office, but half the people ran outside, half people ran inside. I think it was a tornado. If you could have the lights help people show where to go, because when the emergency comes, it's truly an emergency, and people start acting a little funny. And that's what we're trying to say. Once you're connected to PLCs, all of a sudden you can have a lot of fun in what you can do and really improve your factory and what your processes. Then the last part is that advanced capabilities. So now you have all that connectivity. Like I said, now you have this connected ceiling. So now you have all these lights talking. You've got the real estate, you've got power, and you've got communication. What can you do with that? RFID sensors maybe on it, track your pallets, track your forklifts. That was seeming to get popular. It's kind of dying off a little bit right now, but one thing I'm really focused on with our company is air quality. H2S sensors. If you can have sensors that are out there, we're not going to make sensors, but we can wirelessly connect them to our lights. And if there's a leak at a refinery, what's the first thing you do? You know there's a leak, you look up and you look at the 1800s technology of a windsock, see which way the wind's blowing so you can run the other way. But if you can have a light start blinking, tell them, hey, there's a problem, and actually you'll start blinking where the gas is moving and people can start going, and you can tell the control house you've got a problem right away and where it's at. That's a huge safety aspect. So all of a sudden the cost of lighting doesn't make as much sense anymore because when you're actually talking about human safety. Vibration sensors, if you can actually bring vibration sensing capabilities in through the lighting. We're talking to we're actually at a conference with one of our big electrical providers, and they spent millions of dollars just to wire up their factory to get vibration sensors on their big turbines. Well, they actually were using our lights. They weren't connected lights at the time, but what if they could just connect to the lights and bring all that information back and be done? Save millions of dollars just on the connectivity. So there's lots of different things you can do. And that's really what we're trying to show is, hey, there are new possibilities, new ways to think about it. And that's really IoT messages. There's always something out there. It's just how can you use it to utilize it to improve your processes. So now you've got that, like I said, the lighting is a backbone. It's connected to everything. It could be connected to everything if you want, whether it's product sensors, your material handling, factory automation, or robots. Whatever you want to use now, there's some possibilities out there to start doing that. So really it comes down to is what's next? What does this mean for you? Here's that guy sitting in this factory. Now he's got lighting controls. Now he's thinking, what can I do with this? Well, number one, he should probably put some machines there. He's got an empty factory. But actually, this is it happens to be a helicopter maintenance repairs. I took the helicopters out for the picture. But what can you do with that? Well, that's really kind of the key takeaway I want to get you. you're going to see a lot of stuff. You're going to have vendors like myself coming in, talking to you all the time. Hey, we got this new widgets, new capability. Answer's looking for problems, or the proverbial hammer is looking for nails. Don't be a nail. There's all these things out there, and they make Bluetooth toothbrushes. Does anybody have a Bluetooth toothbrush? There is somebody has one. I don't know what you use it for. I don't need it, but they're there. There's all these possibilities out there because they can be done. It's amazing when you go online what people have and what they can do. Do I need it for my garage door? No, I don't really need it, but it is nice when I drive away. Did I close that door? And I could just look and make sure it's closed. But really, the truth comes down to no one knows your plants better than you. No one knows your processes better than you. I can come in and talk. I'm amazed when I come in because I might think I know a process, but there's always that little something different about every process, every plant, every company. But you know it. You live it and breathe it every single day. You know what you're doing. You know what your process is, what your products are. So the question is, you got to ask yourself constantly, what else can I do? And it's kind of the old, it was the old HP commercials. What if? What if I do this? What if I could do this? And come up with, because now there's all these technologies, and we're going to be coming in there, vendors. So, but use us to help you bounce ideas off and try to figure out what can we do to make this faster, better, and do something. Because I'm not saying companies are going to go extinct, especially, I know a lot of oil and gas here. They're certainly not going to go away anytime soon. I don't care how much solar there is and how many electric cars, you're going to still need it. But there's still somebody that could be doing it faster, better, cheaper than you. You can do something different. And there might be that new value add that we don't even thinking about right now. So you got to start thinking about, what are those things I can do? What if I did put a sensor on this one little process or part of the process or my machine, and I can get data? Could I do something faster? Can I save the company, 3% of their production cost? So how can you make yourself more efficient, more productive, and safer? And that's really the key takeaway. How do you use all this stuff and do it? So keep reading, keep looking on the internet, keep talking to us, and try to help figure out what you can do with that. That's really the big key takeaway I've got for you. So I'm around for a little while if you have any questions. I know it was a little fast.
I'm going to bring the mic around just because we do have people online as well.
What's the protocol for the communication with the lights? I'm not sure.
It's actually
Okay.
There's no speaker, it just goes in.
Yeah.
Communication for the lights, there's like 3 technologies out there, but the 2 main ones are kind of a Zigbee style. It's an 802.15 versus the 802.11, which you have in your Wi-Fi in your house, which is a mesh technology. And then there's a Bluetooth mesh. So it's a Bluetooth and a kind of a Wi-Fi or Zigbee. So it's a communication. So each of these lights will talk to each other. And what the difference with that is, instead of having my gateway, which was hang on the wall, and the distance is going to be so far it can go 100 feet, let's say. It can't talk to a light 1,000 feet away, but if it can talk to the next one and the next one and the next one, it'll all connect back. And the beauty of that is actually self-healing. So if you actually have a failure somewhere in that string, it'll just bounce around and find its way back. So the technology is a little different than what you would have for your Wi-Fi in your house, but actually the technology is very similar to what they do use for your lighting in your house, if you buy the smart Philips light bulbs or whoever makes those these days.
They use NB-IoT for the lighting communication sometimes.
That's coming a little bit. I've seen that. I don't think we're using that specifically.
Another technology. How about so the non-wireless route, PoE plus? Is that?
So power over Ethernet.
Right.
Get that asked a lot. Power Ethernet is interesting. It's an interesting technology because now you don't have to run power to your lights. You just run an Ethernet cable. And actually, some companies liked it because now they don't need, union electricians at whatever an hour. They just have an IT person just running a piece of Ethernet cable plugged into a light. You can actually do that for office because the power is like 60 watts, I think is the maximum. I think they're trying to push that to 90, but if you go to industrial, it just doesn't work because industrial lighting, even our really efficient LEDs are going to be over 100 watts or somewhere in there. So it just doesn't make sense. Then the other kind of strange thing about it, if you think about your lighting, okay, now you've got all these lights. We got to have a cable for every single light. And now you got to have a switch from Cisco or whatever. Now you got a big rack of switches, all this complexity to turn on a light bulb basically in an office. So it's kind of, sometimes it makes sense, but it's kind of technology. I don't want to say it's a hammer looking for a nail, but there's places where it works, but it doesn't work for industrial automation. There are wired versions though too. Actually, Dolly is probably the big one, digital addressable lighting interface. That's actually big in Europe, and that's actually 2-wire control to each lights. But you have to add wire to all the lights now and do that, where you lose all the flexibility. That's the beauty of wireless lighting. If you have a plant and you have a machine, you can set up your control and do whatever you want. And then if you move that process or do something, it'll take you minutes to change how your lighting works, just because it's just that simple.
Any other questions?
How sensitive are these systems to any voltage fluctuations or any harmonics you might have in the system? So if you're running a lot of big medium voltage gear and motors, are you
Good
going to
question.
have potential issues?
Well, yeah, but anytime there's voltage spikes, there's potential issues. I've dealt with these my whole career. But, you know, at least our lights, I can speak for us, we design them so they do survive voltage fluctuations. So it's on the line. So the communications then can be affected by that. What are going to be will affect the communication are other things like cranes and big metal things. I actually had somebody who bought a system and took our gateway and put it in a metal cage. That's a Faraday shield. It's not going to work. You can't do that. But bigger issues are more going to be people who have a lot of RF interference. So I had one guy who had some kind of a microwave machine thing doing, and it was just a lot of noise. And they couldn't really get anybody's communication at all working in their factory. So there got to be some of those things. But you know, we've done things to get work around that. So we have higher level, about the highest that are allowed for FCC or whatever. So we can actually do more than what we say, just because we want to be able to survive in these nasty industrial environments. And then we also have the ability, which not a lot of people do, we can change the channel. So even though we're at 2.4 gigahertz, which is really a big spot where most people are in, we can actually choose one of like 14 different channels. So you can pick an area where it's a little cleaner so you don't have interference. So we do a lot to make sure we don't have interference. And so far it's been pretty solid. But you do make sure if you know you have a really noisy area, you know, you might want to do some sniffing, and let's take a look at what interference might be out there.
Share a slide with all the different lighting technologies and wonder whatever happened to sulfur argon with the microwave drive.
Well, personally, I've never heard of that one. There was just a selection of a lot of the ones that are out there, but I don't.
They were supposed to be for outdoor lighting. So you could do a 5 kilowatt single bulb, something like that.
No,
A lot of lighting.
I can't answer that particular technology. I don't know. Anybody else know this particular? Ken, you know that one?
Went the way of plasma. It was just terribly inefficient. It wasn't gonna make it.
Yeah, there's a lot of ideas out there, and you know, it comes down to LED is just simply efficient. I mean, people, when we were at trade shows, we have our light out and it's burning at 100%. People come, they're afraid. I say, touch it. And they're afraid to touch it because they think it's hot, just because, you know, you don't ever touch an incandescent bulb without a glove on your house, or, you know, God forbid, a halogen light or something. You never want to touch those. All the energies go into light. It's not going into conducted heat. And that's what they're so efficient. It's putting all the energy in lighting, and that's what you want.
I've heard before of having issues with power factor when you change a plant over to LED. Have you ever had an issue like that? And if so, how did you address it?
I'll let Ken answer that one. I'm the controls guy.
Yeah, it's actually, this question did come up not too long ago when we were at another engineering firm.
The technology that we incorporated into our systems produces or does not interact or interfere with any harmonics that exist that we have found so far. A lot of times when people started putting LED fixtures and technology around drives, there was a real concern about harmonic distortion affecting because of the frequency changes. And it was a really big thing because we did a NASA test stand that required several high-speed cameras, and we got way off in the woods and deep, but we do have a white paper on it. And I know engineering types like to get all the way down into the weeds. We can make sure that you get that white paper written by our in-house expert on harmonics.
Your question over there?
Yeah, slide that, excuse me, showed LEDs, you know, just getting, like I say, more efficient and more reliable too is the main thing.
Mhm.
Now, the concern would be, now we're introducing sensors, automation systems. What's the reliability of those components? You know, we're introducing new challenges, and the other part, are the staff engineers, maintenance folks going to be able to program these devices themselves, or are we now introducing new needs to bring in outside consultants and yourself, for instance, salespeople to do all of this custom programming and stuff for them?
Great question, and it is a great question. So it's all solid state, so you don't have anything moving, so you're really not going to have problems from from longevity, basically. I mean, even on the controls on our light fixtures, we'll give the same 10-year warranties for them. So I'm not worried about the lifetime of those things. But the complexity, right? That's the whole thing of the whole IoT message. The complexity is just going up and up and up. And how do you do that, especially when your maintenance staffs are going down, down? Hopefully you save time because you went to LED, so now you have all these maintenance people who have nothing to do. But what you're going to have is you have to look at your systems you're buying and how easy is it or how hard is it to program. I mean, I will say, I don't want to get commercial, but we've done tests and we actually brought an electrician in. They said, here's 6 brand new lights right out from the factory on the ground. I want you to hang them. All they told them, I want you to put names on them, name them 1 through 6, put a schedule on them, turn on at 8, off at 5, and go at it. And the guy was able to, the only thing I did is ask for an electrician that has a laptop and knows how to use a laptop. That's all I asked. And he had, in fairness to him, he had done a competitor's system. But he came in, he said, this is the easiest thing he's ever done. He just did it. There was even a wizard to walk you through it to make it easy. He didn't know it, and I didn't tell him because I'm just observing, but he actually went through exactly the right steps, one by one. One time he stopped for about 30 seconds and had to think about it, and then he took the right action and did it, and he was probably done in 20 minutes and had it all up and running on a schedule. So it is simple, and it can be simple if you do it right. Let me give you another nice anecdotal. I went out to a site and commissioned their system, and they had a co-op that was helping. He was in charge of doing everything, got it all running. And I left. Well, 4 months later, a guy calls me up and said, hey, I need to do some work on the lights, and I don't know how to get in. He didn't listen or bother with it. So I said, well, hopefully he didn't change the password. Here's what it is. And he didn't. Never heard from him again. He was able to get in and just do his thing. And it's intuitive. It can be intuitive. I know some might not be, but so you got to look at that. But you want to make it simple because it's got to be intuitive because it's going to happen. You put it up, you're fat, dumb, and happy for 6 months, and then you want to make a change. The machine's changed, something processed, and you want to be able to do that. So you can be simple. Yes.
So one of the things I've noticed with LEDs is because they're low power, the LEDs themselves are very powerful, very easy to overlight.
Yep.
Especially if whatever you're lighting is sensitive to that light.
Sensitive in what way? Because of cameras or? Okay.
And overlighting can actually kill the bulb.
Mm-hmm.
You need a light meter to set the right light levels in the right spectrum because all the controls are in there. You can set any spectrum you want to any intensity you want. You can ramp it up, you can ramp it down.
Yeah, that's where controls, because like I said, people put it in there, they will actually reduce lighting because they said, well, I used to have this light and here's how much I theoretically got, but of course they drop off in light so fast. I mean, it's amazing how much they have, and they're all different levels. So they put ours in and it's bright, so you can control it. But then you get into special things. We actually do make a special light for turtles because there's some beach where turtles are coming in and doing their mating and egg laying and such. And there's a special light today, one special frequencies. We actually have one of those. I don't know how often we sell that one. I don't hear about it too often, but so yeah, you have to be careful. You've got into some weird things, but it is the lighting. It is going to be bright, and it is going to be look at glare. That's the other thing we're really good at. How much some of these are really a lot of glare, so be careful on those.
Hey, Glenn, let me just add is that was a big problem when LED white lighting first came on the scene for the engineering community, especially. You were putting lumen for lumen back up, and everybody's like, "Oh my God, it's way too bright." And that's a function of the biology of the eye. Your eye perceives certain parts of the spectrum distribution curve a lot better. UV on the LED side, high pressure sodium is on the warm side, and infrared side. So it has a lot. It's more than just the intensity of the light. It's the human condition that lends itself to perceiving this type of light much better.
Right. And it's the amount of just because the same lumens.
Yeah, I use half.
You might have double the foot candles of some lights in the floor. So
400 watt metal halide high bay hanging up there. It's 24,000 mean lumens. You could use a 12,000 lumen LED light source, and you're still going to think it's better light.
Yep. Did you have a question on the screen you wanted to?
Yeah, there's one of the comment from one of the online viewers, just Dynasty Technologies. They have harmonic analysis capabilities.
Oh,
So
okay.
just mentioning that.
Okay.
Energy studies, things like that. That's what they do.
Question back
You
there?
Speak in general terms about incentives that are offered through a variety of, federally and whatever else, just general terms.
Yeah, well, and I mean, you have to look at your, it's usually by the power companies. So you got to look at your provider and see what incentive package they have. I mean, there are some, like I'm selling a lot in Oregon right now because their incentives are so great. They're actually getting free lighting and writing checks almost. I mean, some of if they do advanced control. So if incentives, usually you'll get a lot of them will have an incentive like a basic $25 per fixture. But then if you put controls on there, you might get a little extra. But then there's some places, and that's why you have to look at your individual, they'll give you custom. If you do a high level control, custom control, they'll actually analyze how much they're really going to save, and they'll give you a big check sometimes. So it can be good. So look at your locals and if they're participating. I had a company I did, I got it down to 2-year ROI, but the year, if they would have done it the year before, they were still on their program, and they would have saved another probably half a year of, but they pay more for energy or less for energy, but they weren't on the incentive program, so they lost their incentive. It was still a great program to do it.
A question over here.
So it's probably been about 5 or 6 years since I had to do a photometric study, but I think I actually worked with you, Ken, on switching. So the client wanted photometric study that showed the foot candles, and like you're saying, the white light is brighter. Has there been any changes to the programs you use to calculate and model that, or any standards that have recommendations now for LED lights since they are different than?
Ken, I'll let you take that.
Yeah, so IES, which is kind of the governing committee that we use, although they've come out with a lot of opinions and papers about the subject, because I mean, they physically had to change the math processors in the light measuring instruments because measuring the wavelength of LED lighting against traditional light sources just wasn't accurately reflecting what's going on in space. You're referring directly to the programs you used to do rendering important CAD files and doing lighting layouts. The newest software that we run, well, that's commonly available, does account for that. Because we're no longer comparing them against traditional light sources anymore. Most of everything we work on is LED only. So the programs that are being used today, some of the older programs like AGI 32, they updated their programs to reflect the reality of, you're putting when you do your renderings, you know exactly how much light that's going to be available as perceived light, not actual light.
So does it still display in?
There's a derating factor that's built into the program.
Yeah,
When you choose an LED light source, it's just derated to reflect how much lumens you're trying to put in space.
So that'd be like high pressure sodium, like we're using like 0.7 factor now, LEDs use like 0.9.
Yeah, there's a variety of different derating factors written into the software. But yeah, when you're doing comparisons against older technologies, you can get out of whack. But people like yourself and a lot of people in this room today, when they do lighting projects, that's only LED. And that's why we'd like to get involved and make sure that our team does all the renderings for you. But it's not just us, that's available, that's a service that's available in the community in general.
Any other questions? I have one more, Ken. So, Glenn, the reporting side of things, you talked a lot about the control. Any reporting capabilities that people might take advantage of? Occupancy, things like that?
Yeah, well, the biggest thing is the ability to now take, we can give you real-time power of every single light and show you what your energy usage is. We actually have a program that'll just you put in your legacy lighting, what you had, and even how it was running during the day. And it'll actually show you for running last 28 days, how much energy you used, how many dollars you saved. It'll even show you how much CO2 you expended. So, which is really nice because almost every Fortune 500 company, every year they're doing an annual report, and in it there's some kind of a sustainability report. They have CEOs or directors and vice presidents working on this. So now you can actually show how much your energy savings really is nice. But what I find that tools use more as engineers, because now, we're all engineers, we love to tinker with things. They can go in there, see how much energy they spent. Maybe they spent $30,000 of energy in May. they can start tweaking the lights, maybe dropping them 5%, putting occupancy sensors certain areas, and then actually measure it. It'll come back and say, hey, you just saved $3,000 by what you just did. So it's, you actually see the results versus today. It's turn a light switch on and off and you guess what you might have saved for the day, right? So it's actually, the fact you can get real-time power is really nice for that. And then you can get reports showing you what lights are on. And so if you have occupancy sensors, you add a section, it'll actually show you, like, you can see if, are your lights working properly? Are your schedules running? Are people in areas at night maybe they probably shouldn't be, or maybe you gotta light them different or change your schedule. So a lot of different things you can do just from the reporting side.
Any other? Yep.
We see a lot of issues with 480 volt power. It's old dirty power. Have you had any experience where you've installed these systems and where you actually see those power surges come through on 480 volt, where you can actually, we went from 480 to 650 or whatever? Have you seen any of that?
With the controls, I haven't seen any issues. And I know we've been on some 480 volt power, but I can't say we've had any issues that I'm aware of. That I'm sure if it gets high enough, there's going to be something that will go on, but we try to protect our lights and our controls the same. So, but yeah, it's hard to say. So
That could
far
be
so
part
good.
of your connected ceiling though as well too, putting the energy monitoring, putting power meters up there to catch things like that.
Right.
wanted
So
to
if you know
analyze
you've got
something.
dirty, just like
Right.
anything else, you should probably check to make sure. But we've done different things. Our 40 volt lights themselves, we have passive ones because we own some plants that are so bad. You got to put different lighting technologies in there because they're just not going to survive. Yeah, some plants are old.
A lot of dirty power down here.
Any other questions? All right, well, thank you,
All right.
Glenn.
Thanks so much. Appreciate it.
So ISA people and IEEE people, just stay tuned to your emails for the next meetings and topics for the respective organizations. Oh, we still have chicken back there, chicken, deviled eggs. So if you'll make yourself a little plate to take back to the desk, please feel free. And thank you very much.
Thanks.